Hello, everyone, and welcome to our webinar, Fine-Tuning Your Embedding Model with SingleStore. My name is Matt Brown, and I'll be your moderator today. One of my main jobs at SingleStore is to organize these weekly AI webinars, 2 per week, and we'll showcase new AI use cases and new tools and new technologies. I post about these upcoming webinars every week, so if these topics are interesting to you, feel free to connect with me on LinkedIn to stay in the loop. I'd also love any ideas that you have on future sessions or topics or tools that you'd like to see. And speaking of future sessions, if you click to the next slide, you'll see that we've got several great webinars coming up over the next few days. So tomorrow on the 15th, we've got Apache Spark plus OpenAI for personalized banking services. Then the day after that, on Wednesday, the 16th, we've got Accelerate MongoDB apps to drive 100x faster analytics and AI. It's very cool, a new Mongo API that we have, so you can get all of that at speed, performance, and vector capabilities, no code changes. Very, very cool. And then on Thursday, we have Kafka Unleashed, powering real-time AI with streaming data. Unfortunately, I don't have the RSVP link for that yet. I hope to have that later today. But if you sign up for either the other two, you will get the link for the Kafka Unleashed. Also, heads up, I know some people have said we want to sign up for all of these. We have an auto registration button in the works. It's not quite ready yet, but I want to preempt that question. It is coming soon so that you won't have to register individually for all the different topics that you want to see. So anyways, getting back to today's topic, we would love for you to participate in the discussion throughout the session. We've got a Zoom Q&A button at the bottom of your console. We have an internal mission statement to try to answer 100% of audience questions throughout the session, and even if that means following up with folks afterwards, since sometimes we get tons of questions during these sessions. But all you'll need to do to get your question answered is make sure that you log in with your name and email address. We won't be answering any anonymous questions. So if you logged in anonymously, just take a minute, log out, log back in, and this time include your name and email address, and we will look forward to chatting with you during the session. Also, we would love for you to try out the technology that we're going to be showing today. So anyone who tries it today will be entered for a chance to win either the new Ray-Bans Meta smart glasses, the smart glasses powered by that LLM, or the newest AirPods Pros from Apple. All you need to do to be entered into this raffle is just click on this link. I'll put it in the chat in just a minute, or visit that QR code. That'll take you to the same place, and just log into SingleStore. If you're already a customer or you already have an account with SingleStore, no worries. Just visiting today and logging in today will make you eligible for this raffle. If you've never signed up, it's really easy. It takes 30 seconds. We have a free shared tier, which we'll talk about in a little bit. So it's never been easier to try it out and follow along. Let me introduce our speaker for today. Alex Peng is a growth engineer at SingleStore. His formal training was from the Stanford Computer Science program, and he has expertise in big data, machine learning, and AI. He is now a regular speaker at our weekly webinars on data and AI. Welcome, Alex. I'm excited for your session today. The floor is yours.
Awesome. Thanks so much, Matt, for the intro. And yes, just emphasizing again, we would love everyone to try out our demo today for fine-tuning embeddings with SingleStore. Oops, I'm gonna go back. So do make sure you check out the raffle link here, fine-tuning raffle, to kind of get your hands on the demo and hopefully win a pair of Ray-Bans or a new pair of AirPods. Great. So, so for those of you who have attended a few of these webinars before, a lot of this is going to be familiar to you, but just to level set and make sure everyone has the same sort of background coming into this, I wanted to talk a bit about the emerging architecture that we're seeing for LLM applications. And this emerging architecture is really centered around this new information retrieval an augmentation paradigm that we're seeing called retrieval augmented generation. And that's essentially when we take an end user's prompt to a Gen AI app, which is based on an LLM technology like ChatGPT or Google Gemini. We take that prompt and we use that prompt to retrieve information that's relevant to our query, so that we can return that information to the LLM in the hopes that it will not hallucinate or kind of fabricate facts or figures or information in its response. Because when we use LLMs over, say, proprietary commercial data or healthcare data, for example, the LLMs by themselves might not know the specific facts and figures of a client that you're working with or a patient that you're working with. And so we need to augment the LLM's abilities with data. And that's what we're going to be diving a little deeper into today. We're seeing this retrieval augmented generation paradigm emerge amidst this kind of new AI stack architecture where we see users interacting with their LLMs, end users, consumer users interacting with their LLMs through conversational UIs, through SaaS applications, on websites through widgets and plugins, and then at the next layer down, we see developers interacting with these LLMs and serving up information from these LLMs to the UI through APIs. And so that's probably the layer that most of us are familiar with here. That's going to be programmatically interacting with LLMs and, not just LLMs, but all the infrastructure related to LLMs. So, data connectors, augmenting LLMs with potential vision and audio input, so on. Finally, at the bottom layer, right, we have what we at SingleStore believe to be kind of the lifeblood of LLMs, and that's going to be your contextual data store, right? That's going to be the place that holds all of the information that's important for your LLMs to understand as they produce responses and queries, or responses to the queries that your users have, whether they're internal company users or consumer users, right? And so SingleStore is the only platform that offers both fast millisecond latency lexical search using traditional SQL and SQL-like languages, as well as vector search, or what we're now seeing being called semantic search, which is sort of a fuzzy search over unstructured data types like PDFs, images, text doc, unstructured text, in a more company-specific context, it may be customer support tickets, right? That's going to be all this information that you are hoping to kind of get a fuzzy match against using your user's query to augment your LLM and in the hopes that it doesn't hallucinate. Inside the contextual data layer, obviously, we have, there's even more complexity. Inside of SingleStore, we have this really a powerful new capability called SingleStore Notebooks, where we've kind of bundled some compute with your data storage. And we're going to be actually working with SingleStore Notebooks today, showing how to fine-tune an embedding model right alongside your data, right? So it sits as close to your data as possible and is able to interact with your data, as in as low latency as possible, right? Obviously within the kind of traditional contextual data layer, we have, like we mentioned earlier, we have, structured and unstructured data, and, all of the kind of associated technologies, open source technologies and proprietary technologies that have kind of emerged to support these different data types. And we'll kind of skip over the really nitty-gritty details here for the sake of time, but happy to answer more questions. Great, so let's dive a little bit into the reason that we're all here today, which is to learn how to fine-tune an embedding model for improved retrieval performance over your proprietary or custom data or private data, right? And to really understand what it means to fine tune an embedding model, we have to understand what embeddings are, right? And for many of you that may have only used ChatGPT or kind of consumer facing LLMs, embeddings are something that's probably wholly unfamiliar to you because it's really kind of abstracted away and really only a term that's familiar to LLM developers. But embeddings are present everywhere in the LLM space, right? Not just for information retrieval, but actually also embeddings are used when you just type a query into ChatGPT and you'd like it to respond to that query. Whenever any text is fed into an LLM, actually, it needs to be embedded. And that essentially means that we take a chunk of text, like the quick brown fox jumped over the lazy dog, right? We take that chunk of text and then we encode the meaning of that text into a list of numbers, which we call a vector, right? That list of numbers can, in the case that we're interested in, that list of numbers can be used for information retrieval over a vector search compatible database, a database that contains other vectors of information that we're interested in. Or it can also be used, just to actually allow to pass into the LLM so that the LLM can actually understand what it is you're talking about, right? Because it doesn't understand language on the level of letters and words, but instead on the level of vectors, right? So let's talk a little bit more about this information retrieval piece, right? I really like this graphic from a recent 3 Blue 1 Brown video. Shout out to any fans of 3 Blue 1 Brown on YouTube that are joining us here today. That shows how embeddings work visually. And so that list of numbers that I described before, you can really think of them as a list of coordinates. In this case, we only have 3 coordinates. We're plotting in 3D space, right? But in the real world, vectors are lists of thousands of numbers, corresponding to thousands of dimensions, and that's because vectors have to encode. Or embedding models have to encode a really diverse array of inputs across which you have to be able to relate information from many different domains into a higher dimensional space that can then be used more efficiently and effectively for later retrieval. And so let's take a look at this graphic. We have this example, 1 mole of carbon dioxide, right? And for those of you that are familiar with chemistry, 1 mole is a unit of measure in chemistry. It's a unit of measure of a certain element, right? In this case, carbon dioxide. And we want to, in this case, if we're embedding mole, right, or we're embedding the phrase 1 mole of carbon dioxide, we'd like it to be close to, in the vector space, close to 6.02 times 10 to the 23, which is Avogadro's number, another kind of chemistry specific constant, right? We probably would not like for it to be embedded close to the concept of a mole on skin, right? In like dermatology, or like a mole, the animal, because when we go back through our data set later and we're searching for, chemistry related terms, we'd like to group together similar terms and ensure that dissimilar terms, even though they might share like the same actual words and spelling, dissimilar terms are not grouped together. And that way, our search results are more relevant, and the information that we actually pass on to the LLMs is relevant as well, because LLMs will not only hallucinate if you don't give them enough information, but especially they'll hallucinate if you give them the incorrect information, right? Imagine you're asking for help on your chemistry homework, and when you do your RAG of your database, your text snippets and your image inputs are, of like, the moles the animal, and it's like facts about moles, right? That's really going to confuse your LLM. So some considerations for embedding, just really quickly. Embedding is really going to be useful in cases that we're considering unstructured information. So, text, images, videos, audio. You're going to want to be careful, especially about embedding information that requires special access or sensitive data, because when we embed information and put it into a vector database, when we search over that vector database, we're performing a similarity search across the entirety of the vector database. And so you're going to want to make sure you're gating access to sensitive information inside of gated vector databases, right? And not storing them alongside vectors or vector databases containing vectors that don't have special access privileges. Now let's talk a little bit more about fine-tuning embedding models, right? So we just talked about what an embedding model is, and that's, you can think of it as a black box that takes as an input words or images or text, or text or images or video or audio. It takes that information and then encodes it into a list of coordinates or a list of numbers that really tries to capture the meaning of similar words and concepts and images and audio snippets. It really tries to group those closely together in a high dimensional space, and then group dissimilar concepts far apart, right? And the reason that the embedding models do that is that when we retrieve it, we get more relevant results, and our LLMs consequently hallucinate less, right? Now let's think about like the specific case of when we have custom terms or company specific project names or product names, or even just like a very industry specific term inside of our database, right? Like, let's say that we are working on the open source project, Jupyter notebooks, right? And we are working with an AI coding assistant that is helping us work on the project. Well, hopefully we'd like for any of the information that we retrieve over our database, containing any of the queries that we use over our database containing the term Jupyter, to return Python or Python programming language related concepts and text snippets and ideas, right? Not Wikipedia articles that are about planets in the solar system, right? The embedding model out of the box, most embedding models out of the box don't know to capture that difference, right? If you take a look at, say, for example, OpenAI's only available embedding model, which is called Ada, right? That's a generally available embedding model that's pre-trained over a really big kind of data set, right? Containing all of the Wikipedia articles, Google search results, some of OpenAI's like proprietary training data, scientific journal articles, right? And so, when you use an openly available model, a generally pre-trained embedding model, you're going to get more of the results. Like, you're going to get planets as your kind of search result when you search Jupyter instead of Python, right? It's sort of contrived example, but hopefully you can extrapolate it and see how it can really kind of expand to contain really any industry where you're using industry specific terms, concepts, ideas that are not kind of generally recognized. Your retrieval performance is going to suffer, and your LLMs will get information that is either not as relevant as it could be, or in the worst case, just straight up incorrect, which is going to cause it to hallucinate, right? What's the solution to this? We need to teach our embedding models these specific terms, right? And teach it to group together terms that we think should be similar, and not and push apart or map farther apart terms that we believe to be, or that we know over our custom data set to be dissimilar, right? We can create these kind of input output similarity pairs or triplets with, we can either manually generate these by hand, but we in the age of AI like to think smarter, not harder. And so thankfully, this is actually a process that's very easily AI augmented and automated. And I'll show everyone today how to do that with SingleStore and LlamaIndex. Great. So just a bit more about what SingleStore is. SingleStore is a database to transact, analyze, and contextualize data in real time. We operate on-prem, in the cloud, and in hybrid environments. We are multi-cloud. Today, we're actually going to be developing on AWS, which is actually what our free tier databases run on. And we'll show everyone how to sign up for our actually all new free tier and get up and running and start, fine-tuning embedding models on their custom data sets today. Just a few quick metrics on some of the customers that we have. And I'm just gonna, just for the sake of time, we're gonna go over this because we do have a pretty long demo today. This is what SingleStore Notebooks looks like, but we're gonna get to see that really quickly. So I'm gonna skip over this as well. But really at the highest level, the reason we think SingleStore is the best database that you could use for Gen AI apps is that we are not like a traditional vector database or vector only compatible database, in that we believe that your vectors should sit apart from your traditional relational database, right? But in fact, we believe all these things can and should sit under the same hood. They should be able to operate at millisecond latency. They should be able to, you should be able to perform hybrid search over your data. You can do traditional lexical matching against your data and fuzzy, semantic search. And, all these capabilities, including pipelines for fast ingest, combined to make what we believe is the world's best database for generative AI applications. Great. So let's talk a bit about our demo today. I'm going to go ahead and start sharing this. Let's see here. Oh, and do feel free to submit any questions that you have in our Q&A. I see Akmal, one of our other developer evangelists, just joined, and he should be able to answer those questions as they come up. I will also do my best to answer questions during and after the demo. Let's go ahead and share this. Great. So before we get started, I'd like everyone to take a look at the cloud trial sign up page. And I believe you should also reach this page if you register for our raffle. And this is basically the fastest way to get up and running with SingleStore right off the bat. All you have to do is enter in your information, your name and company email address. And since I'm already, set up, it's going to bring me straight to the page. But after a few clicks through our wizard, you should be on this homepage here. And what we're going to do today is we're going to first spin up an AWS SingleStore instance. We're going to import the code demo that should be shared out with everyone today into SingleStore Notebooks. And then we're immediately going to walk through step-by-step how to fine-tune an embedding model and use it with SingleStore using this really cool library called LlamaIndex, which we are actually fully integrated into. So once you've hit this homepage, and not to worry, If you're not able to follow along every single step, this webinar will be recorded and that will be shared out as well. You're going to want to go ahead and click this little group button, add group button under the cloud tab. And you're going to want to spin up if you're using a starter workspace, this is where you'd spin up a starter workspace. Otherwise, if you'd like to use another cloud provider, you can use the standard workspace, or if you'd like to customize your computes and the storage size, then you can use a standard workspace. But we're going to be using a starter workspace today. And we can see immediately the starter workspace with the compute and databases or the compute and the first database is spun up for us. And we can go right into our notebooks tab under develop here and import the notebook that we have today. And this everyone should be able to download this from the GitHub link that I believe is shared out to everyone. But I'm just going to go ahead. Oops. And upload this. Oh, whoops, it's already uploaded. We can just click into it. But once this is just to show everyone how to upload the file or the notebook, you can just upload it in and click import notebook, and that will bring you right to the notebook. But we're going to click into it here. Great. So we're going to be walking through this notebook right now, but you'll see at the very top here, you're going to want to make sure that your notebook is connected to your database, your starter workspace and your database. And you'll see why in just a second. But it essentially gives your notebook access to or the ability to directly interface with the workspace and database that you just spun up. So just a quick overview of what we're going to be doing in this notebook here today. I'm going to full screen this really quickly. First, we're going to be preparing the data. We're going to be generating the training data pairs using a really cool Llama index abstraction called generate QA embedding pairs, which basically, as you'll see, automates that whole process of generating the training data. Next, we'll fine tune the model, which Llama index also makes super easy in a single line of code. And then in the third step, we're going to be actually benchmarking our new fine-tuned model against both OpenAI's generally available model and an open source model which is freely available over Hugging Face. And that's actually really important because whenever we're fine-tuning models, right, we want to make sure that we're actually improving them. We're actually getting and squeezing better performance out of them through this whole process. Otherwise, there's not much point, right? Or we could even be actually regressing on our performance, right? And so having a good benchmark is always important. And for the data that we're going to be working with today, we'll be working with the Uber and Lyft 10Ks. No worries if you're not familiar with like financial documents or anything like that. You can just think of this as kind of a drop-in replacement for the data that you are interested in. Your personal data, your private data, your company data that you'd like to fine-tune an embedding model over. Today, we're just going to be working with the Uber and Lyft 10K PDFs. Finally, we're going to be evaluating our new fine-tuned embedding model using SingleStore as our database to retrieve from, right? And so we're going to be using some really cool Llama index abstractions that let us basically chat with our database, in just a few lines of code. And I'll show everyone how we're going to do that. Great. So just kind of going over each cell here, I'm gonna, for the sake of time, and so we also have time for questions, I'm gonna be, going through this at a pretty quick pace, but do feel free to ask questions. I will try to get to as many of them as I can. Here, we're just kind of installing some packages importing, some of our necessary classes from Llama Index. Here we're downloading the actual, Uber and Lyft 2021 10Ks. And here's the first kind of fine-tuning concept that we're going to be running into today. And that's going to be our training and validation data sets, right? Whenever we fine-tune a model, really any machine learning model, but in this case with an embedding model as well, we're going to want to set aside, at least a training and validation data set. Sometimes there's also a testing data set, but just for the purposes of today, to keep it as simple as possible, a training and validation data set. We're going to want to set aside, a data set that the model will actually train on, that it will compute over to compute over to adjust its model weights, such that when you run any queries through it, kind of similar custom terms are grouped together, dissimilar custom terms are pushed apart, right? All those concepts that we talked about earlier. That's our training data set. For our validation data set, we're kind of hiding that from the model, and we're using it after the model finishes training on the training data set to actually confirm that the model is not just sort of memorizing how to group together certain terms, and not actually learning, right, the kind of general facts and information in the kind of data that we're giving it, such that it's able to such that it's able to generalize, in this case across, financial documents or 2020 or 10K documents, right? Those specific, industry specific terms and custom concepts. So this is just some kind of data plumbing just to load our training data, right? And here's where we generate the embedding fine-tuning pairs, right? We're going to generate a question and a text chunk, which is used as context for that question, as data, which ends up becoming eventually, a whole corpus of fine-tuning data that we use for the fine-tuning process, right? And the idea behind this is that the model will learn to associate, the concepts in a certain question against the kind of text chunk that the model should return to the user, in the case that, a question, that exact question, or a more kind of general question in that kind of in that kind of semantic space comes up, right? So in this case, we're using OpenAI. We're using GPT 3.5 Turbo, which is, one of the cheapest models available from OpenAI to these synthetic, query text chunk pairs. We save that information into a JSON file. And next, we're actually going to run the fine tuning, right? And this is going to take, a little while. For the sake of time, this is not a live demo, but instead, this is something that we really encourage everyone to try out for themselves. You're going to set up your fine-tuning engine with the Llama Index Sentence Transformers Fine-Tune Engine class, which basically takes in as arguments our training data sets, our validation data sets, and really importantly, our base model, right? So that open source Hugging Face model that I mentioned earlier that we're going to be evaluating against, well, that's actually going to be our base model, right? And we're going to be tuning it or changing the weights of that open source model to fit our custom data set. And, the hope is after this whole fine tuning process, we have improved performance over, not just our base model, but also over, a closed source, API only model like the one from OpenAI, which, is presumably best in class, right? And so you're going to run fine-tune engine.finetune, right? There's obviously more parameters. You can set the number of epochs. You can set the number of, you can set the training loss. If you're kind of much more interested in tuning the hyperparameters, there's a lot of space to kind of tune that here, but for the sake of time, again, we're going to be kind of glossing over this exact detail. But if you're interested, do feel free to ask questions about it. And here we're just going to be returning our fine-tuned embedding model, right? After having fine-tuned our base model, we have a fine-tuned embedding model that we can use for retrieval augmented generation inside of LlamaIndex, or using LlamaIndex as our kind of LLM framework. So here, this is just a really quick evaluation section. Again, evaluating against, OpenAI's text ADA embedding model, the open source model that we use as our base model, and also our, our fine-tuned model. And it's going to be a really kind of simple evaluation metric where we just consider the hit rate of the model given a certain question, and we're going to be using the information retrieval evaluator from the sentence transformers library to help us out with this. Not to worry, there's a lot of different ways. Not to worry if you don't necessarily understand all the steps in this process. There's lots of different ways to evaluate your model. Maybe even the best way is to just like have maybe 5 or 10 questions or queries that for sure don't work or work very poorly with an OpenAI model or a generally pre-trained embedding model, and then trying that with your embedding model, after training and validating that embedding model, right? But just to show this approach really quickly, here we're just importing some more libraries that we're going to be using later. This is kind of the way that we define the hit rate metric, where we basically say, we have a hit if, after returning the top K documents, and we define what that K is. After retrieving the top K documents, it's a hit if the relevant document is within that top K documents, and it's not a hit if it's not. That's kind of the naive approach here, but there's also the information retrieval evaluator that you can also use from sentence transformers. If you'd like to get a little more into the weeds, that gives you a bunch more metrics that I won't get into the details of right now. But that really lets you get into the kind of the nitty-gritty of like how your fine-tuned model, specifically your fine-tuned sentence transformers model, right, compares against the base model. And just really quickly here, we'll be able to see that, from, my past fine-tuned model, we have a hit rate with, the OpenAI model. We have a certain hit rate with, the base model. And I'm just going to scroll past some of the cell output here. And then we also get a certain hit rate with our fine-tuned model, right? In this case, you're going to want to obviously drop in, your custom data and, your your data that you're using for your specific use case to get, the numbers that are going to be relevant to you, right? In many cases, you might even find that fine-tuning is not the right approach, but if it is the right approach, you can easily get, 5 to 10%, maybe even as much as 15% improved retrieval performance, specifically on hit rate, right? Compared to, the same size parameter open source model, right? And so you're getting basically, just unequivocally better performance for the dollar, for the same amount of compute that you spend on retrieval. So definitely an approach that's worth checking out. So we're going to really quickly just kind of skip through the rest of this evaluation stuff here. And I want to really quickly give everyone a quick, kind of just primer on how to actually use your fine-tuned model and test it out on your personal documents. And that's really just going to be all using LlamaIndex. We're just going to be loading in our 10K documents using this simple directory reader from LlamaIndex. There's a bunch of kind of data loaders inside of LlamaIndex that you can use, for like HTML documents, for image, for audio, for PDFs. In this case, simple directory reader kind of goes into a directory and picks out the best possible image loader or best possible document loader for a specific data type. So since we have a directory of PDFs, it's going to use the PDF loader. It'll load that into our Python notebook. And then here we're actually able to connect to our SingleStore database instance that goes all the way back to the reason why we, hooked up to the database here. And then we can spin up our vector store using this line here, SingleStore vector store, with our embed model defined as fine-tuned model, right? And so that way, running this line of code basically creates the tables, the columns, and embeds the information for you so that you can retrieve over it later, right? And so we define our embed model upfront so that we're using the right, fine-tuned model for the embedding of all of our, relevant information here. Finally, we're going to define an abstraction in LlamaIndex called the vector store index, which basically lets us actually spin up the database and then store it in or spin up the database and allow LlamaIndex to talk to the database. And right here at the end, this is kind of hopefully the end result that everyone gets to. We can actually do RAG over our database by initializing it as a query engine, which lets us, which is an abstraction or class in LlamaIndex that lets us essentially directly ask, text questions to our database and have responses returned to us, with citations and with information that we've retrieved from our database. Great. That was a lot, I know. That was a very dense webinar, lots and lots of concepts covered here. We do have about 15 minutes for Q&A, and I'm sure we're going to use probably like all of it. Matt?
Yes, indeed. You've got a ton of questions still outstanding. I know Akmal is working furiously to answer as quickly as he can. I'll go back to some of the ones that we couldn't answer that came in early. One is, what is the benefit of fine tuning? If we could use prompt tuning with just a couple of examples to make the model understand what we want.
Yeah, that's a really great question. So fine tuning, I always see as a sort of final step that you take after getting as much low-hanging fruit as you can out of the way. And low-hanging fruit, in my mind, includes prompt tuning, or basically just stuffing information in your prompt that you give to the LLM so that it's better able to understand your question, basically, right? Prompt tuning is a great approach in many cases. If you have a really complex data set and you're worried about maybe inference costs, which costs more per token in your prompt, fine tuning can work out to be almost as effective, not just as effective as prompt tuning, but cheaper in the long run, because you kind of do the upfront cost of fine tuning or training your fine tuned model, and then once it's trained, as long as you're not kind of adding new data or adding new custom kind of terms or concepts to your data very often or frequently, you'll be able to use it for a very long time and kind of reap the savings from having a fine-tuned model.
Awesome. Here is one from Amen. What is the recommended minimum number of training data samples for fine-tuning embedding models?
Yeah, good question. So I think, the unsatisfying answer is that it depends. A good rule of thumb number that I've heard is about 100 examples. The reason why we use AI to generate these examples is that, you know, using AI, you can get to 100 examples really quickly. And then what you can do is after you've generated the examples, you can kind of go back and kind of hand verify them or modify them as you see fit, right? And that's, oftentimes a much faster approach than like literally typing out by hand the examples that you think are best. Although, obviously in that second approach, you're probably going to get, you know, much higher quality data. So it's always kind of a push and pull of like, what are, the time resources that you have at hand to manually create high quality data examples, which are always going to win out, especially for, training and fine tuning machine learning models, right? And, what's this model actually going to be used for, right? Like, is it kind of high stakes? Like it needs to be as good performance as possible. What's good enough? These are all things that you're going to want to, kind of decide before you start fine tuning or really doing any sort of like tuning of your RAG pipeline, and kind of choose the best solution that fits your needs.
Got it. Akmal, I know you have been furiously typing throughout the session. I wonder if there's any good questions you wanted to pose to Alex or any just questions you wanted to share with the audience while we have them.
I think there's a couple still outstanding there, open there, Matt. I don't know if Alex can have a look at those. They might be specific to your demo, Alex. So there's one from Anurag, which says, what are we using as ground truth? So what are we sort of comparing against, I guess, in terms of determining, whether we are actually getting accurate sort of results? So that's kind of an interesting question, I thought.
Yeah. I mean, I think this is why, this is why I kind of think of embedding and, similarity as a very fuzzy kind of matching, a very fuzzy kind of matching algorithm as opposed to an exact science, right?
Yeah.
What does it mean for something to be 0.99 similar instead of 0.98 similar? Does it mean like, like the, the animal mole that we're looking at in question is like, a few less hairs on it or something? Well, I don't know. You're going to have to actually, you're going to want to kind of maybe set out or define like, okay, this is like 0.9 similarity. This is like 0.8 similarity. This is like 0.5 similarity. You can do that approach. You can also, just have the machine learning model figure it out, right? In the approach that we're taking, right, I sort of misspoke when we talked about generating the training data set earlier. I mentioned that we would be creating triplets of data, right? Input and output, and then, a similarity score, right? But in the approach that the kind of generate QA embedding pairs class takes, right? The kind of abstraction that we get from LlamaIndex, that just is an input query, right? Like what animals like to dig in the ground, and then an output retrieved text snippet, which is like, like the first paragraph of the Wikipedia article for moles, right? If you give the model a bunch of examples like that, high quality examples, right? The idea is after training and validating and testing, right, it's able to map together similar concepts and, map further apart dissimilar concepts.
Good stuff. I see one here from Emrule. Thanks for the great presentation. By the way, you got a lot of compliments, Alex, so kudos. But Emrule asks, have you fine-tuned sentence transformer model? What would be the approach for BERT? e.g. word embeddings?
Yeah, that's a really great question. Off the top of my head, I don't know like an abstraction or like a library that offers a way to fine tune BERT models as easily as you can, fine tune sentence transform models. In principle, it's possible. You'd probably just have to kind of go further down the abstraction stack. You'd probably have to use, like PyTorch or something to actually fine tune, a BERT model, right? And you'd use a lot of these same concepts. You'd want, a training data set, validation data set, a test data set. You'd want to be able to benchmark, the BERT model that you end up fine tuning, so on and so forth, right?
Awesome. And by the way, stay tuned, everyone. We do have a BERT webinar coming up. So stay tuned for that. I don't have an RSVP link for it yet, but stay tuned. Alex, I see one here from Ashish. Quick question. I have a particular code base and I want to have my LLM response produce the result with the same style. The issue here is the fine-tuned data is not huge. What would be the better option or path forward according to you guys? Please help me out.
Yeah, so this is a question I think actually asking about how to fine tune an LLM as opposed to an embedding model. And just to remind everyone, like, fine tune an LLM as opposed to, an embedding model. And just to remind everyone, an embedding model is the model that actually transforms input data into vectors, right? And an LLM takes in vectors and turns it into text, right? So you can kind of think of like they're almost sort of flipped in that sense, right? At a very high level. Obviously, for people that are more familiar with the details, you'll know that's not 100% accurate, but I just want to make sure everyone kind of is able to understand what we're talking about here. If you want to fine tune an LLM, back to the question, you're going to want to make sure, again, that, your fine tuning data, your data set, your fine tuning data set, right? Input questions and output text, right? Like, functions or code snippets that conform to the style of your database. You're going to want to make sure that's very high quality, right? So, you're probably going to want to make sure you go through your fine tuning data set, hand verify, verify by eye, like that. These examples are like gold standard. Like this is exactly how you'd like the code in your database to be written. And then, have, if you aren't getting good enough performance, if you feel like you don't have any examples, you can always, AI augment that fine tuning data set generation process. Might take annotating more examples by hand. I would also, just like the other kind of person asked, I'd also check and see that you haven't gotten some low-hanging fruit already, like by, just stuffing some examples in your prompt or, like prompt tuning, that sort of thing.
Awesome. I think we maybe have time for one or two more questions before we announce the raffle winner and wrap up here. Alex, this one is from Sachin. Which loss would you prefer for tuning embedding? How would you create negative samples? It's easy to create positive examples comparatively.
Yeah, that's a good question. To be honest, so two parts to that question. What's the kind of loss threshold that you're setting for fine tuning embedding? To that question, I would say you're going to need to actually run the fine tuning process and kind of look at the loss curve. And you can set checkpoints as it goes and evaluate as it goes, right? You can train these models for a very, very long time, and the loss curve kind of decreases logarithmically, and it's going to be up to you to kind of make a judgment call and say what's good enough for my data set. And then for the second part of the question, how to create negative samples, I believe that is a capability available. That is a capability available to you if you kind of go further down the abstraction layer. If you kind of are fine tuning from fine tuning the models using say for example like PyTorch, right? For the purposes of this presentation, using the libraries available to us in Llama Index, right? I'm not 100% sure that's possible. Though I would check the Llama Index documentation for the kind of exact capabilities around negative samples. But good question.
Cool. Akmal, I want to give this last one to you. So there was a couple questions before you arrived in the room, Akmal. Questions like, is SingleStore a vector database? Like, help me understand what this is. I saw someone else asked, I found SingleStore when I was Googling Elastic. Could you just tell me a little bit about the difference? So I wonder if you could give like a high level answer to those types of questions about what SingleStore is and how it's positioned in the market.
Oh, yes. So we are an enterprise data platform now. So I think that often we get asked this question, how does SingleStore compare against, say, the likes of pure vector database products out there, Milvus, Weaviate, Pinecone, and so on. And so the main point there is that we do not just vectors. Obviously, you could use a SingleStore purely as a vector database if you want. And by the way, the reason I was late attending in the beginning is I was just attending a training session internally on tuning SingleStore for vectors. So surprise, surprise. And all of that good stuff is going to be out in our documentation. So best practices, guides, indexing, all of this kind of thing, which will show you how to tune the product to deal with vector indexing specifically. I know we're almost out of time, Matt, but I think the main point to make is that we do far more than just vectors. Okay, we can do relational, obviously, but we do all the other good stuff: geospatial, time series, JSON, and vectors have been there for quite some time anyway, although that support has got a lot better since the start of this year. So we are an enterprise product that does not just vectors, but a whole bunch of other good stuff as well.
Great answer. Thank you, Akmal. I'll go ahead and announce the raffle winner. Quick note, reminder, we've got several awesome sessions coming up. Tomorrow is Akmal's Apache Spark and OpenAI for personalized banking. Day after that, we've got Accelerate Mongo to drive 100x faster analytics and AI. Check that one out as well. And then Thursday, busy week, Akmal, Kafka Unleashed, powering real-time AI with streaming data. I have put 2 out of 3 of those links in the chat. I'll get the third one as soon as I can, but hopefully you can RSVP for at least one of those, and we'll see you later this week. The announcement you've been waiting for. Today's raffle winner is Jay. I'm not even going to try to pronounce that last name, but you are a principal software engineer at Walmart Labs in San Francisco. Congrats.
Oh, congratulations.
Thank you for joining us. If that's not you, don't give up. We're going to give out one more winner, one more prize by the end of the day to someone who has tried out Alex's Python notebook. So we put that link in the chat earlier. It will also be in your email. I'll just one more time in the chat. I'll put that raffle link here in the chat. So again, all you need to do is log in order to be considered. And fingers crossed, hopefully you are our next raffle winner. Thank you so much, Alex. Awesome presentation and demo as usual. Akmal, thank you for joining us for Q&A as well. And thank you to our audience. Hopefully we'll see you later this week. Bye, everyone.
Thanks, everyone.